Great.
Perfect. Okay, so and who's that joining you?
Emilio, he's my partner.
Okay, so good
Sure.
afternoon, Emilio. And I'm Carlota Cruz from Universidad Politécnica de Madrid, and I'll be hosting your pitching today. And
Great.
I'll give you a few instructions. You have 10 minutes in total. You have between 3 and 5 minutes for the pitching, and between 5 and 7 minutes for the Q&A for the jury. And well, please start sharing your screen, and just after you finish your deck, please give us then the screen control, and the floor is yours, and the time starts, your 5 minutes starts right now. So please.
Okay, great. So my name is Ben Weber. I'm the CEO and co-founder of Stor Water, where we are identifying and locating non-revenue water for small and medium-sized utility companies. Ultimately, we're focused on non-revenue water because it accounts for over 40% of potable water worldwide. This is a real historical use case of the Buenos Aires, Argentinian water utility company. What we see of all the system delivered volume, all the water entering the water distribution system, only 43% of their water is actually making revenue. But what we're focused on at Stor Water is these real historical leakages, which we see here is represented by 35.8% of their water in their water distribution system. Ultimately, these water managers are often facing difficulties with old IT infrastructure, attracting and retaining IT talent, and ultimately having siloed data architecture that doesn't allow them to optimize the data they do have. Basically, we need to move to a digitization and an active leak control solution. The current methodology is called minimum night flow techniques, takes between 24 hours and 1 week to come back with an answer of the leakages. But as we move into a real-time data to create real-time water balances, we'll ultimately be creating active leak control, which we'll talk about in a moment. The opportunity of the market is large and growing. We know that digital twins are a large and growing market, but if we look at digital solutions specifically in the water market, we see that over $21.3 billion are spent in 2016, with over 10 billion of that being spent in the EU and the United States alone. If we look at where the spending by application is actually being spent, we see that over 50% of that spending is being spent in the water distribution network, and that's only exemplifying the problems that water utility managers are having with this part of their vertical. So the tool that we're trying to build is an operator aid tool for network operating centers. Ultimately, this will centralize dispersed distribution network data and create a real-time operator aid tool to help the operator make decisions in real time. What we see here on the right-hand side is actually the downtown Madrid area. This is broken into different distribution systems in the water distribution network. What we're utilizing behind is different mathematical models to predict where these different distribution leakages are inside the system. What we see on the bottom-hand side is one of those mathematical tools that we're utilizing. This is called the real-time water balance. This is the amount of water entering the water distribution system minus the amount of water that we're counting leaving the distribution system at the smart meters of the households. And if we see there's a large gap between the amount of water entering versus the amount of water that we're counting that's leaving, that means that water that we are missing is probably being lost in leakages. If we move to where we are in the development process of our solution, we see that we've already moved through our proof of concept. This is a machine learning tool built with three UK utility companies. We see in the top right-hand side, this is the inlet volume and the inlet pressure for that water distribution system. In the bottom left-hand side, those blue spikes represent real historical leakages. So on the right-hand side, what we have is that first column is the real historical leakage, the target. Then we have three different machine learning models that we have actually trained on these two different data points. And we made the final overall ensemble, which is the global average of these three different machine learning models to predict if a leakage has occurred. This model was able to predict in 6 hours if a leakage has occurred, which represents at a minimum of a 4 times faster detection rate with a 69% accuracy. We have an all-star team. My name is Ben Weber. I'm the business development and technical account manager, but my background goes into nuclear power generation in the US Navy, so I'm a systems engineer. My partner, Emilio de Jesus, is the product owner. He has a master's in renewable energy, and he's the project manager as well as data analyst. Our CTO, Guillaume Duran, is a full stack engineer that has experience with AI and machine learning at scale, as well as Python at scale. We have several advisors, but most notably, Frank Rogaya is the Chief Innovation Officer of Aqualia, the 4th largest water utility company in Europe. If we look at our traction, we see that we've already been working with several utility companies, and they've already provided us with different data sets. We already have over 400 million lines of data that we're building our proof of concept and our MVPs on. We're currently going through the final sales cycle with Aqualia to enter in the Horizon 2020 Reways project. This contract that we're talking with Aqualia should be worth around 160,000. Again, we're in the final stage of the sales cycle for this. We've been invited to 3 different sales channels, 2 incubators, and 2 different EU consortiums. Ultimately, the part of the market that we're really trying to target, and this is what makes Stor Water interesting, is that the competitors are all focusing on large utility companies providing water to over 100,000 people. We see that those kind of solutions are providing water to about 47% of the population and only 441 different distribution systems. We're focusing on small and medium-sized utility companies providing water to less than 100,000 people, representing 53% of the population. But the big difference is that they operate many more distribution systems, over 49,500 water distribution systems. And this goes into the conversation of why we're building an open core solution to break down the barriers to entry for these small and medium-sized utility companies to enter into a data analytics solution. Ultimately, what we see is that we'll provide the raw data visualization for these utility companies open source, but we have different price points for the level of advanced analytics that they're looking to utilize from our solution. Ultimately, my name is Ben Weber. You can reach me at ben@storwater.com or amelia@storwater.com, but we're looking forward to answering any of your further questions.
So thank you very much. You nailed it. 5 minutes. So congratulations on that.
Thank you.
And please, if you are so kind to turn on your camera so we can see.
Yeah, sure.
Thank you very much.
No problem.
So we will start with the Q&A. And so
Sure.
Who wants to go first? Javi?
Yeah. Well, thank you very much first for your presentation. I think it's very exciting what you're doing. I would like to understand, how do you integrate with the existing SCADAs or the existing, well, system that use the utility companies already to manage the information that come from the field?
Yeah, sure. That's a great question. I mean, the answer is that not all utility companies are ready to interact with a solution like this. But what we see is that there's a growing demand for water solutions. So what you see is that these water utility companies are starting to look at their data lakes and trying to organize them. And so what we're trying to do is go through that process at the early stages of build these different data sheets, which will allow for an API for them to directly connect to our solution. So that's completely correct. Like there's a big a worry at that stage. But in the first 3 to 5 years, when we're working between 3 and 15 water utility companies, we've already found those companies that are at the process at which they can utilize this solution. And what we anticipate, or what we know what will happen, is that the rest of these water utility companies will catch up on their digitization. And in the next 5 to 10 years, they will need a software solution for data analytics.
Okay, so thank you for your question and for your answer, Ben. And Angelica or Luis?
Yeah, I can just continue. I'd like to also thank you for the presentation, very interesting. I would like to know if you already have pilot customers or pilot municipality with whom you're going to work in the future, or a letter of interest or something?
Yeah, sure. So we already have a signed letter of interest from Aqualia, and we're working through that 160,000 euro contract. In fact, what is going on right now is that contract is from a Horizon 2020 project. And so there's now a negotiation between the innovation department, which has that money from the European Union, and the IT department to let go of the responsibility of that data. So we're already moving through that process with Aqualia, as well as Vicid from Sweden. But again, this is why we're looking for, an EIT or a climate accelerator program that can also help us advance on that. Because what we see is that they're interested in testing our product, but we have a proof of concept now and not an MVP. So what we need to do is move from this early stage into the next stage where they can immediately test and see the results of our solution. And that's kind of the roadblock that we continue to run into, because until this point, we're completely bootstrapped and we have no outside investment. And so we're having not a problem, but we're working on transitioning from this proof of concept to looking for our first investors to be able to move to a full MVP.
All right, thank you.
So thank you. And just to finish with, we have 2 minutes left.
Sure.
To answer question and answer. So Luis, please go ahead.
Thank you, Ben and Emilio for the presentation. Thank you very much. I'm not an expert on water management, so maybe I'm a bit confused or I missed something. But I guess the companies have already this system to identify or to look for the leak for the losses of water. No, I guess. So I guess this is a evolution of the current systems in that sense. And the question is how it's in the line of what Javier said, how easily would be to deploy this system in the current infrastructures?
Sure. So you see it from two parts. So actually water utility companies are not very well tracking their leakages. And that's what you see is that the European Union on average is leaking 26% of their water, the potable water in the water distribution system. In America, it's over 35% and the worldwide whole is over 40%. So the techniques that they're currently utilizing, which are not utilizing real-time data, they're utilizing a minimum night flow, which is they take 4 readings between 3 and 4 a.m. and they try and average that over the day. But what we see is that technique is having complications. It's not accurately detecting these leakages. From a different perspective, there are some water utility companies that are trying to start to build this. But what you see is that other water utility companies do not want to contract them because they are direct competitors. But coming at it from a technical sense of being a technical provider, on the outside of not being a water utility company, this is where water utility companies are starting to be interested in technical solutions outside of the space to come in. One last thing that you said is, so I understand the complications with the infrastructure today, but what we're working with right now is building a Kubernetes solution that will allow us to deploy this solution onto any machine without utilizing their operating system, and this will make it much easier. That goes back into the fact that the target market we're focusing on are those 49,500 water utility companies, and making it as easy as possible for them to get this onto their computer versus the competitors who are looking at those 440 water utility companies, and thus they don't need a solution like this.
Mm-hmm. Thank you.
Okay, so thank you very much. It's been 10 minutes, so it's perfect.
Great.
You will get the assessment results next week. So
Okay, great.
thank you very much for your time, and we wish you the best of luck.
Thank you very much.
That's all. Thank you very much.
And thank you for having us. Talk to you guys soon.
Bye.
Goodbye.